Hello and welcome to Algebra 2 tutorial. Right now we're going to take a look at a new way to define a parabola. So far we've been looking at parabolas and we've been defining them as equations, like y equals x squared is the parent function. And then as we make them more complicated and we transform them, we looked at standard form, vertex form, and factored form. All three of those types of equations give us a parabola. We're going to look at another way to define a parabola now, the focus and the directrix. Two weird words that we don't usually associate with a parabola, but it's a very interesting way to define a parabola, besides the regular x squared definition from the equation. So first, we need a visual to see what this focus and directrix look like to give us a little context here. So that's where we're going to start. How can we define a parabola based off these things called a focus and a directrix? So here's a little visual for us. A focus is just a point. It'll be very clear why it's called a focus just here in a second. A directrix is a nice horizontal line usually away from the focus. And I don't know why it's called a directrix. Not gonna lie. But a parabola is all of the points, E is going to be on our parabola, that is equidistant from the focus and equidistant to the directrix. You can see that in this case they're both 2.97 units away from each. And then there are other points that are also equidistant. So if I move this, if I move point E around, you can see that there are other places. Here's another point that is equidistant from the focus to the directrix. They're both 6.37 units. And if I do all of those points, these are the only points that work, hopefully you can see that U shape a little bit that we call a parabola. I could make it even more obvious by tracing that point, and you can see a nice perfect parabola coming up. Now, just to make sure we can understand this, one point that's definitely not going to work is, say, the point right here. This is not on this parabola because this distance from there to there is not the same as this distance. They are not equal. So therefore, this point is not part of this parabola. That doesn't work. So you have to be equal distance from the focus to the parabola, and then from the parabola down at a right angle to the directrix. And you can change what parabola you're looking at by taking the focus and moving it. So if I move it closer to the directrix, here's it real close, take a look at what happens to the parabola. Still a parabola, but this one is vertically stretched, or it has a horizontal shrink. But it still makes a parabola. That point E on the parabola is equidistant from the focus to the directrix. And so depending on where you move this focus, that will change the type of parabola you get. Now, one interesting way to change that focus is if you grab it and move it under the directrix. Now when I draw this parabola, it's still a parabola, but now it's upside down. So any kind of parabola you want, you can still make it using the focus and directrix. To make the parabola open up, the focus is above. To make it open down, the focus is below. Alright, so that's the general idea. Oh, one more, I didn't forget to tell you why it's called the focus. It's called the focus because if you shine a light inside a parabola, it will focus the light to this one point, just like a satellite dish does. And so a satellite dish is a parabola, and it focuses all the radio waves to one point, the receiver in the middle. That is a parabola. Kind of cool. All right, let's go back to some numbers to see if we can actually turn a focus and directrix into an equation. So here we have a parabola, the directrix, we got to put the focus on ourselves. And then we're going to write the equation. This takes a little bit of effort. It's not the easiest thing, but let's go ahead and do this. So our directrix to our parabola, I'm going to take our vertex right here. This distance from the vertex to the directrix is 2. That means from the parabola to the focus must also be 2. So this point right here, it wasn't labeled before. This is what is called the focus. It should always be inside the parabola. Imagine the light being bounced into the center. That is where you will find your focus. And this easy point is 2 units from the focus and 2 units from the directrix. Now that gives us a little bit of conceptual visualization, but nothing for an equation. We want an equation. To do that, we have to pick some random point over here. All right, we don't know where this point is. It is x, comma y. We don't know where it is. But what we do know about this point is the distance from the focus and the distance from there to the directrix is the same. Now the way I drew it isn't great, but our numbers will be good. So the distance from the focus to this point and from that point down to the directrix must be the same. So we can use that idea that these two line segments are equal to make this equation by using the distance formula. This point right here, the focus, we know what that is. That's the point 0, comma, negative 3. I'll give me a negative. There we go. And this point down here, we kind of know something about that, actually. We don't know how far side to side it is. It's the same as this number, x. But we do know how far up and down it is. It's negative 7. And the distance from this point to this point must be the same as the distance from this point to this point down here. And so we're going to find the distance between those two and set them equal to each other. Now the distance formula. All right. If it's been a while, you can learn it as we go. The distance formula starts with a huge square root. And what you do first is you take the x's and you subtract them. And then you take the y values and you subtract them. So our first points, the focus and this imaginary point over here. We take the x's and we subtract them. So x is the first one, minus 0. Now we're going to take the y values and subtract them. So we have y minus a negative 3. So I'm going to put another negative 3. All right, let's keep working with this side for a little bit, and then we'll go ahead and fill in the other side. This looks really complicated, but it gets simpler really quick. X minus 0 is just x squared. Plus, now this stays a little complicated, y plus 3 squared with a square root over it. All right, let's fill in the other side and practice this distance formula. Now we're going to find the distance from the green point to the red point down here. So again, we subtract the x's and square it. X minus x. Hopefully you can see that will simplify very nicely. Plus, now we subtract the y's. Y minus negative 7. And then we can simplify this one a little bit. X minus x is 0. 0 squared is gone. And then on the inside, you've got y plus 7 squared. All right, now it's time to really simplify this and make it look not quite so horrible. We've got an equation and a square root on both sides. So what we can do is simply square both sides. If I square one side, square the other, and a square root cancel out. So that goes away on that side, and now this goes away on that side. So now all we're left with is x squared plus y plus 3 squared is equal to y plus 7 squared. Now this still looks pretty rough, but we can do this. So first we need to multiply this out and multiply this out. So we have x squared plus, now I'm going to do this in my head, but hopefully you can kind of see the pattern. This is y squared, then we do y times 3, 3 times y, that gives us a total of 6 y's, and then 3 times 3 is 9. Then we multiply this one out, so y times y is y squared, y times 7 is 7y, 7 times y is another 7y, so we have a total of 14 y's, and then 7 times 7 is 49. Whew, you don't believe me, this is getting easier, do you? Let's keep going, we're almost done. Now we have to get the y's on one side and the x's on the other. But something kind of nice happens. If we subtract y squared to both sides, those go away. And then if we subtract 6y to both sides, that goes away. 14y minus 6y is 8y. And to cut down on the steps, let's do one more step. If we're going to get the y's on this side, let's move everything else to the other. Minus 49 minus 49. So 8y is equal to x squared, and 9 and negative 49 make negative 40. Now we have to get y by itself. Divide both sides by 8. Make sure you divide the whole thing by 8. Now we've got y by itself. I'm going to write over here, nice and big. Y equals, and then 40 divided by, well, we've got to divide everything by 8. So in front here, the x squared is divided by 8. Here's an easy way to write x squared divided by 8. And then divide the other one by 8. 40 divided by 8 is negative 5 there. And we now have our finished equation. Alright, so I know that's really long and really hard. Hopefully you won't ever have to do that too much, but that is how it goes. You set up two distance formulas. Alright, remember you subtract the x's, and then you subtract the y's. And to get those points, to get those numbers, you are going from the focus to some imaginary point. You don't know anything about this imaginary point. It's just x, y. And then straight to the directrix, just like that. That's how you pair those up. The square roots go away. That's kind of nice. And the really hard part is multiplying out these squared terms. You can use FOIL or however you know how to do that. Then it's just a little bit of algebra to move things around. Alright, hoping that makes some sense. Let me give you a few practice problems to work on to get the focus and the directrix. Alright. So here's one for you to try. See if you can do that the exact same way. Good luck.